All right, good morning all you wonderful people. Let's go ahead and get this started today. As always, oops, wrong button. As always, I'm gonna start off with a little bit of what we did the day before. Let's go ahead and start with, I think we did not do these last two problems, so we're gonna go over them. One of them is kind of a bit of a hassle, but that's okay. Also, I wasn't here yesterday, so I had to make a separate video to upload that one. Yeah. So it's a little bit of a different format, I think. I tried to keep it the same as I could, but I don't know. A few things might be different, sound and video quality or anything like that. I'm not really sure exactly how that works out, but I do have that video up from yesterday, so if you haven't watched it, go ahead and watch it here. Make sure you look through my channel and find all the videos because I get people asking me for links. Well, once you find the channel, just subscribe to the channel or click on the channel icon and you should be able to see all of the other videos I've uploaded. I've uploaded just about every video that we've had of every lesson so far this year. So it should all be there. Okay, anyway, let's go ahead and get started with this one here. So quickly do a quick reminder. Quick review, I guess. First thing we want to do is we want to isolate this radical. Isolate this radical as far as we can. So I'm going to go ahead and add 1 to both sides. And that should get our radical isolated. But we do run into another problem, and that is we are going to have to use a few more steps because on this side here, I have 2 separate terms, and those 2 separate terms can be a bit of a hassle because as I square both sides, right, I got to do parentheses to show that I'm multiplying everything on both of those sides. So square on both sides. So on our first side here, the power undoes the radical, so we no longer have that radical, which is good. That's what we want. We want our variable to get as by itself as we can. But we do kind of run into a problem on this side, and that is I have a group, and that group is being squared. And when you square a group of numbers in the parentheses, you will oftentimes have something like this, and when you do this, you're going to have to use your FOIL process to simplify it. So on our first side here, nothing's going on, everything's the same. But I am going to have to use my FOIL. So remember, FOIL is first number, so first number in each group, which is x times x, which gives us x squared. And outside numbers, so I have our outside numbers x times 1. So in this case, it would be 1x, but I don't really need to put the 1 in front of it because anytime you just see a variable by itself, it's just 1. You just imagine that it's 1. Now for the inside numbers, 1 times x is also x. And outside, or sorry, last numbers, our fourth step is the last 2 numbers in each group. So I have 1 and 1. 1 times 1 is 1. Now I'm going to do a little bit of a writing saver. It's not, I mean, it does save a little bit of work, but if you're writing this on your own, it would probably not be really great to use this method, but it's a little bit more confusing. But because I'm writing all of this out by hand on a mouse, it can be a little bit too much. And you know, if I had to write out this whole thing every single time, that would take up a lot of time. And I'm trying to keep these lessons a little bit on the short side. So what I'm going to do is I am going to move this over. Now, the reason I'm going to move it over, I forgot to explain, is sometimes in algebra, you can use your basic algebra to solve for a variable. But if you have an x squared, that usually means you are going to have 2 solutions. So an x squared means, again, that's like 2 variables means 2 solutions. or possibly, I should say possibly 2 solutions, because there's a chance that, as we learned from yesterday, sometimes things just don't work out. All right, so let me go back over to yesterday. So sometimes you get what we call an extraneous solution. You do the right work the right way, but you get something that just doesn't work out. That's the extraneous solution. So remember, we got to check our work. So check everything you get, because especially with exercises like this, when you're dealing with roots or any kind of root like square roots, cube roots, you always run the risk of getting something that doesn't work out. So it works one direction, but it doesn't work the other direction. It has to work in both directions. So anyway, I gotta move all my numbers to one side, because that x squared means that I am going to have to use a method of solving that quadratic. We could either use square root property, completing the square, quadratic formula, or my favorite that works with most of these, the double bubble method. I forget what they actually call it in its real name now. I've been calling it that for so long, I actually kind of forgot what they actually call it, but that's okay. So I'm gonna also get rid of this 5 at the same time, and I'm gonna put it underneath the other like term. So I have a regular number, so I put it under the other regular number. Okay, so 5 minus 5 is nothing. X minus x is nothing, so I got 0, which is good. I want it to be 0 if I can. But now I have to sort all this stuff out. So x squared, and I have x plus x plus x. So that in this case would make 3x. So I end up with 3x, and 1 minus 5. 1 minus 5 is going to be 4. And I sometimes we get variables that will cancel out. So if you remember from last week, we had some that canceled out. So we only had one variable again, and we could use our ordinary algebra to get the answer or the solution. But in this case, we still end up with a quadratic. So I'm going to use my favorite method, and that is I call it double bubble, but I also call it the Loif method. I call it double bubble because the first thing you do is write 2 parentheses. And Loif is just foil spelled backwards, but you kind of say it like a way a British person might say life. So, oi, bugger, how's your life going? How's the old life? I don't know. Sounds like I don't know, middle northern England accent. Boy, buddy, you going up to Edinburgh, huh? Anyway, so last numbers. So we work with our last number here, which is -4. Now keep in mind that there is a sign there, but the first thing I need is 2 numbers. So I need 2 numbers that multiply to 4. And I think most people's first reaction would be 2 times 2. But I'm going to tell you right now, that's not right. That's not going to work. Because the next step of this is you have to make these add up. Or in this case, we're going to have something a little bit different, but they have to combine to make 3. And that's not going to work out, because in this case, if I have 2, my only options are 2 minus 2, which is 0, or 2 plus 2, which is 4, and I need 3. So that's not going to work out. Now, with this type of factoring, this is something that you might have learned in Algebra 1, but you know, I understand that might have been a long time for some people, or maybe your teacher just, I don't know, did something that just didn't stick with you or something. Who knows? But there are other methods. You can research those other methods, use whatever you want to use to get through this. But in this case here, again, life is last number, so I need 2 numbers to multiply to my last number. And like I said, they have to in some way combine to make 3. Okay, so that takes care of that. But now we have the sign. Now this sign is the most important thing. And this is why I usually have the Loif method, is because it reminds you that you gotta look at this sign. You're working backwards, right? So we're going backwards with this, or I don't know, my screen's mirrored, so I don't know which way is backwards that you're going to see it. But we're working backwards from the direction that you would read it. So in this case here, one is positive and the other is negative. Because if you remember, this last number is multiplied to make -4. And the only way to get a negative is to multiply a positive and a negative together. If you multiply two negatives, that's going to be positive. Multiply two positives, still positive. So the only way, again, you can do that is if one is negative and the other is positive. But now the question is, which one is positive? So if, just to try it out, if I made my number 1 positive, that would be 1 minus 4. Which 1 minus 4 is not positive 3, but it is 3, just not positive 3. We're trying to get positive 3. So if I put the positive on the 4, 4 minus 1 is 3. So this has to be the right combination. Now, once you're done with this, that's the easy part, right? So that's the oi, like oi, you bloke. I'm kidding, that's a horrible accent. But you know, you just gotta have fun with things sometimes. So here we have our middle term that adds up. So that's the middle part, the oi. And then we also have the first number. So first number is gonna be x. These are usually the easiest to do when you have nothing in front of the x. No negatives, no numbers other than 1, right? Okay, so now we can check it again really quick, because again, with this part especially, whenever I'm looking at work, this is usually where students kind of make the wrong thing. They'll get a combination that works, but it works at a glance, but then when you try it again, it doesn't work. So let's go ahead and quickly test it. X times x is x squared. And outside is 4x. Middle is -1x or minus 1x. So 4x minus 1x is 3x. So that works out. And last numbers in FOIL. So -1 and +4 multiply to -4. So still works out. Still good. So we did not make any mistakes. And again, don't be afraid to check yourself. Anybody can make mistakes. Now we have to continue solving them. We're going to use this zero product property. And I think I said this in the last lesson. I mentioned kind of what I mentioned zero product property, but I did not really explain exactly what it was. So the basic of zero product property, so a product is a number that you get after you multiply. So zero product. So 0 times a number equals 0. That's the zero product property. Anything times 0 is going to be 0. So if I were going to make this equal to 0, what numbers could I plug in for x to make the whole thing 0 out? Now remember, 0 times anything is 0. So if either of these numbers becomes 0, then it will be a solution. Now, usually I get, well, what about 0? Well, 0 is not going to work out in this case here because there's a lot more going on. If I plug 0 in here, I will get an actual number, I will get an integer that is other than 0. So in other words, I get something besides 0, but I want 0. So the best way to do this is to split it into two possible equations. So that's what I'm going to do. I'm going to break it into x minus 1 equals 0. So I just move the 0 over to this side. So it's a little bit easier to work with because I think more people are familiar with using the variable on what I call the first side or the left side, because when you read it, you go left to right. And I also have the other equation here. So x plus 4, like that. Now I have the number I need to plug in there to get 0. So continue using your basic algebra. Now this part's also kind of easy. I've had some students that will ask me, do I really need to do all this every time? And not really. I think some students we'll kind of figure out, you know, it's just the opposite of whatever was in the bubble. I said plus, I said opposite. So if they see a -1, it should be a +1. It's just sort of the backwards of the sign. So if I plug in 1 back in here, 1 minus 1 is 0, and 0 times whatever this is going to be 0. But I also have another possible number, another possible solution. Now, I don't say possible solution. I don't say solution, I say possible solution. Because here I have another one. So -4, if I plug in -4 here, -4 plus 4 is 0. 0 times whatever this is going to be, because it's not going to just be 0, it's going to be a number. In this case, I think it's going to be -5, but whatever it is, it's going to be 0. So that's why it works out. Now we're not done yet. We still have some more stuff to do. And that is, we need to plug it back into the original and see if it works. All right, so let's go ahead and take x as 1, and I'm going to plug it back in here. So square root 1, actually it's going to be 5. The first number is 5 minus 1 minus 1 equals, and then x is also going to be 1, so I'm going to plug it in there. All right, so let's go ahead and evaluate this. So 5 minus 1 is 4, which it's still under the square root symbol, so it's going to be root 4. And root 4 is going to be 2, and 2 minus 1. Now at this point, I just have to check it to make sure it works out. I mean, I could go back, I could do more and prove it all the way, but I can just ask myself right here. 2 minus 1 is 1. Yeah, that works out, that's true. So that checks out, it works as a solution. So I'm gonna go ahead and box it up because that is a solution. Now I don't know if I gave myself enough room to write this next one. I'll try it though. I kind of wrote a little bit bigger on this one. So 5, now there's going to be 2 negatives because I have a negative in the original. And this 4 will also bring its own negative. Minus 1 equals -4. So drop that in there. And I know I kind of wrote this little line above here, so you can't really see the radical, but it's there. Now in this case, it's 5 minus -4, which is taking away a negative. And if you think of a negative as being something bad, well, if you take away something bad, that's good. So you're essentially adding these numbers. So this is 5 plus 4, which 5 plus 4 is 9, and we're still taking the root of 9 equals -4. So this part here, we haven't worked with any of this, so we're kind of done here. So let's go ahead and evaluate the square root of 9. So this is 3 minus 1 equals -4, and is this true? No, that's not true, because 3 minus 1 would be 2, and 2 does not equal -4. So this solution, even though we did all the right steps, we did this problem exactly the way we should, just didn't work out. And sometimes it be like that. All right, sometimes you just do all the right things, but it just does not work out. An important life lesson. So there we go. We only have one actual solution. The other is an extraneous solution, which means, again, we only have one solution in this case. But again, that's why it's important to check it, especially in this case, because you could be the best math person, calculation person, whatever, and if it doesn't work, it doesn't work. All right, so it's just like if you've ever worked in customer service, like if you've ever worked like at a Walmart, there's always some lady who is always willing to say you're not doing your job right or something like that. I want to speak to your manager, all right? Even though you do all the right things, for whatever reason, they're still mad. All right, it's just like that sometimes. All right, this next one's a bit of a tough one. Now I checked the homework. I don't think any of them are this tough because there's a lot of steps, there's a lot of stuff going on. And this problem is going to be a little bit more than the usual, but that's okay. You know, you will still learn a lot of principles from this that will help you in the homework. But I think it's still very worth it going over this. So first thing I'm going to do, I usually write it in a little bit of a lighter color first, is I'm going to need to square both sides. Now, this problem does have a little bit of extra writing on it. So what I'm going to do is instead of putting this 2 here, I'm going to kind of skip that and put an extra t plus 2 in there, which again, that's what it means when you have a group squared. It means you got to have 2 of those groups. So now that we have 2 of those groups, I'm going to write them out so that way it makes it easier for me to FOIL them in the next step. It just cuts out a little bit of writing. And again, if I was writing on a whiteboard or the smart board, I wouldn't have a problem writing this out. But just because I'm using the mouse and it can be a bit of a hassle to write, and my writing is a bit slower, and I know that does have a tendency to it has a bunch of other effects. So let's go ahead and continue on with this part. We need to FOIL this part here. So t times t is t squared. Outside is plus 2t, excuse me, 2t, and then my inside term is also plus 2t. And last term is 2 times 2, which is 4. Now we have, it looks like we have a lot to do, but it's not going to be that much extra work. But I am going to need to move all of these to one side because I have 2 t squares. Now, when you're solving a quadratic like this one here, and there are 2 t squares, we want to do a couple of things. We want to keep the t positive. That's the first thing we got to do. We want to keep the t square positive, or in this case t square, but any square variable. We want it to be positive because it makes it easier to factor. If you have a negative number and you try factoring it, that can be a bit of a hassle. It works and you can do it, but it's extra work. So the first thing I got to do is decide which side t squared belongs on. So I can either minus t squared on both sides, but that's going to cause it to be negative. So I am going to add t squared to both sides. So plus t squared plus t squared. And that means I got to get rid of all of this stuff. Everything, got to get rid of it. Plus 2t, which I'm going to have to put over here as well. Now, normally I would take care of these and put them together, but I'm going to try something a little bit different, and I'm going to put all 3 of them together. So you just got to remember all 3 of these terms are together, which again, normally I'd write the whole thing out, but again, I'm also trying to save time, save space, because it takes a little bit longer to write with the mouse. And sometimes it kind of tires my hand as my handwriting gets worse. So this cancels, cancels, cancels. So everything on this side, gone. But again, that helps us out because we want that number to be 0. It helps a lot to have it as 0. Now I'm going to go ahead and add these numbers together. So t squared plus t squared gives me 2t squared. All right, now again, I have 3 terms for 2t, so that's going to be, I'm going to have to put all of them together again, take all of them into account. Normally, we're not used to this because we only add 2 terms that are like at a time, so that's going to be a little bit different. Now, this gives us a little bit of a break here because 4 minus 4 is going to be 0, so I only have 2 terms, not 3, because if you had a quadratic with 3 terms, a quadratic trinomial, you would have to use the double bubble method or something else like, again, quadratic formula, completing the square, or square root property or something like that. You're going to have to try a different method. You could also try graphing too, which I guess works out. But I'm going to show you mathematically first. So now I have a little bit of an easier time doing this because rather than using those methods, I'm going to use what I call reverse distributive. So everyone's familiar with distributive property. So if you have a distributive property, right, there's a number in front of a parenthesis. So you give that number to both of the numbers in the parenthesis. But this one's backwards. So if you imagine distributive property like Santa Claus, right, Santa Claus gives presents to everybody. Well, back in my day, he only used to give it to good kids, but nowadays I think he gives more to the rich kids. But anyway, you know, free stuff is free stuff, so I'm not going to complain. But supposedly he gives things to everybody. Therefore, he is a distributor of presents. So if we think of the opposite of Santa Claus, and that is somebody who takes things away, that's kind of like the government organization, the IRS, right? When you make money, they will take your money, and they try to take more money from richer people. They try to, but rich people often have a way of getting out of it. So what we got to do is we got to find out what we can take from these 2 numbers. So I want to take something. Now check out what they both have. Now we're dividing, because remember distributive is multiplying, so opposite of distributive is dividing. So they both have 2. Okay, let's see. They both have 2, oopsie. And they also both have a t. So look at this first person. If I take a 2 and a t, he's only left with 1 t. He had 2 of them, but we took 1, so he only got 1 left. And now take a 2t, or divide 2t by this. So 6 divided by 2 is 3. T divided by t is 1, or again, we took it. But either way, 3 times 1 is still going to be 1, so it's still there. Now, it's still set to 0. So we are going to break them into 2 equations. Now, just to kind of match what we did earlier, I'm going to put normally I wouldn't do this, but I think I'm going to start doing this because I think it makes people a little bit more careful with what they see. So let me go ahead and break it into 2 equations. So 2t equals 0. So that's the first one here. And t plus 3 equals 0. So I need to find out what these numbers need to be in order to become 0. So 2 times what gives me 0? So 2 times, well, in this case, 0, or again, you can divide both sides by 2. 0 divided by 2 is still 0, so you would have gotten the same answer. And over here, you could just minus both sides, so I get t equals -3. Now, again, I have 2 possible answers. These aren't solutions, they are possible solutions, all right? Sort of like if you've ever had to buy replacement parts, especially from AutoZone. I feel like AutoZone is usually the worst place for this. You go into the AutoZone and you say, hey, can I get a car part for such and such? And they'll give it to you. You go home and you try fitting it into your car and it doesn't fit. And you're like, should have gone to O'Reilly's. All right, you guys probably don't know that, but it's kind of like that. You know, if you've never had that, sometimes there's someone who sold you the wrong thing. They sold you like the wrong batteries or the wrong parts, you know, or maybe your friend, you ask your friend, hey, can I have some pencil lead? And they give you O5 when you need O7, all right? So sometimes it seems like a solution, it seems like it'll work, but sometimes it just doesn't work. Now let's go ahead and plug in our numbers. Now for this first one, I'm gonna do it to save myself some writing. I'm gonna say t is 0, this is 0, and this is 0. So okay, we don't need as much of our imagination for this one here, just because again I don't want to write. If I was writing on a whiteboard or something, I'd have no problem doing every single step. So let's go ahead and look at this one. 4 minus 2 times 0, which 2 times 0 is 0. So 4 minus 0 minus 0. So 4 minus 0 minus 0 is still going to be root 4. So I took care of all this here, equals 0 plus 2. So I'm trying the first one, I'm trying 0 out. So is the square root of 4 2? Yeah, that works out. That is a solution. The square root of 4 is definitely 2. Now that saves me a little bit of time and writing on the first one. But for the second one, I think I'm gonna have to write everything out. So I just cannot skip this one. But at least I saved some time. 4 minus 2 times negative 3, because again, I'm replacing this with negative 3 squared. All right, now let's go ahead and work this problem out. So sticking to our order of operations, I'm going to go ahead and, well, nothing happens to the 4, but if I multiply, I can do that. Negative 2 times negative 3, so negative times negative is positive. And taking care of this one here, so I have negative 3 squared. So the negative, the outside negative is not affected by this number here. So negative 3 times negative 3 is positive 9. Now, again, this negative moved down. This negative disappeared because of negative 3 times negative. Negative times negative is positive, so that's where that went out. And for some reason, I put a T here when I should have put negative 3. And here I have 2 minus 3. Just think of it as 2 minus 3. And that would be negative 1. Now, right here, you can already see that there's going to be a problem if you were listening to yesterday's lesson. A lot of times, if you have a square root that results in a negative, that's oftentimes a non-working solution. Or again, we call an extraneous solution. But anyway, let's keep going. You never know, something might happen differently. 4 plus 6 is 10, and 10 minus 9 is 1. So square root of 1 equals negative 1. Okay, well, again, maybe something different might happen. Take the square root of 1, you get, well, 1. 1 equals negative 1. This is a incorrect solution. That does not work out the way it should. So even though we had 2 possible solutions, we only have 1 real solution. So we get rid of that one. Okay, that one's extraneous, so we throw it out. So we only have 1 solution. Only one thing works out, and that is 0. 0 is the only thing that works out. All right, that's enough of that lesson. Let's go ahead and switch over to this one here. This one's actually going to be a short one, I think. largely short. Oopsie. We got to switch back to the actual one here. Ooh, got a bit of smoke in my lungs. It was a crazy night last night. I don't know if anyone caught that, but the Vans store broke down or burned down the other day or yesterday. I was there. I'm not sure what it was or what it could have been. I don't know. Maybe I'll ask somebody on the inside what it was. I hope it's not an arsonist. But judging by the way the fire looked to begin with and where it kind of ended up at, I think it might have been like bushes, is my guess. I hate to think that there's an arsonist out there or something like that.
Wait, which building?
The Vans building.
Like the one that's like down there?
Yeah.
But like, okay.
Yeah, the one in the canyon. The whole thing's gone.
Oh, damn. Feels bad, man.
Yeah. Yeah, and
the Vans building in Curly Valley, right?
Yeah, it's gone. I mean, like the fire was big. I was over at my mom's house, and
I know.
What's that?
I was I walked out of my room to get some air. I look outside, and there's just a big like wall of fire blowing east.
Yeah.
I said, "What the heck is going on?" And then my mom came back up. She showed me a picture from Facebook, and Vans was on fire. I said, "Oh snap!" I thought someone was just burning their trash or something.
Yeah, that's what I thought too.
A bunch of trash.
Yeah, because my mom lives way up north, and I got a house down in down by Vans. So I look outside. I'm like, hey, look, there's a little fire. And I thought it was like a bush fire right across the street, and I jump on the top of my brother's house, which is right next door, and I look at it and I'm like, I can't tell what it is. From where I was looking at, it looked like it was like at first I thought it was right across the street. I climbed the house. I'm like, okay, the fire is coming from across the not across the street. It's way further out, and I saw it behind these water towers, and I thought, it's probably the boarding school. So then my dad comes out, he's like, let's go be nosy. And we drove down there. And as we got closer and closer, I'm like, oh shit. Oh shoot. It's almost near my house. So as we kind of go down and down closer, I'm starting to get worried because it's like, dude, I really hope my house is fine. And we got closer and closer because like the closer and closer we got, the more worried I get because it's like right there. So we went through the back way, not the way through the main road by True Value, but we went through the that really long windy road that kind of goes up the side to I don't know where it goes to. It's like it goes into like the KFC housing area. But we went there and I was like, I was all scared, and then like so I stood in front of the house, and then the cops chased me away from the house. So I was like, dude, this is my place. Why are you chasing me away from my house? I was kind of worried because like by that time I got down there, the flame was like really, really big. And I got worried. So I kind of went back and I went up to the canyon and watched the rest of it. And then by the time it kind of got small enough to where I wasn't worried about it anymore, I just like, oh shoot, man, that's crazy. But anyway, that's the whole story with that. Now it's gonna be part of this video. But I wonder if it was arsonists because like as I was driving home, I thought to myself, I wonder if all these riots going on are influencing people. Like maybe some person was watching the riots on the news and thought, oh man, look at all those burning buildings. That looks like fun. And they did it themselves. They took it upon themselves to do it because like that's the thing that's happening in the news right now. There's lots of fires, and I really hate to think that somebody is doing that, to that. I don't know. If it is an arsonist, there probably are a couple of other reasons because that land is not being used and that store has been shut down for like a while now. Anyway, let's go ahead and continue on. So working with complex numbers and kind of get a better understanding of the complex numbers and plot the complex numbers on a graph. Now this part is a little bit easier to remember, and if you remember with complex numbers, they have a real side and an imaginary side. All right, so there's a real side and imaginary side. So what we're going to do is when we graph it, the real side is the horizontal, the left and the right axis. And then you will also have an imaginary side. Now, in a regular graph, we would call this the y-axis. So the y-axis would be the up and down, and that's all you have to do is just sort of replace numbers with that. So let's keep this graph in mind as we move along. So again, remember there are 4 possibilities. Like if you remember from the last lesson that we had on complex numbers, there is, you can have either I, -1, -I, and 1. So that's the kind of wheel that spins around and points to which number it is. So it has to belong in one of these quadrants. So if you remember from, that'd be like quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it's got to belong in one of those or somewhere along the axes. All right, here's a slide that we've already seen before. And it's just reminding you that 1 is equal to the root of -1. And I square is also equal to -1. So again, I think we've already done 2 lessons with this, so it's gonna be mostly review at this part. But again, the other thing that's important is remember every number has a real part and an imaginary part. So it'll make much more sense once we start using the principles. So all we have to do for this one, and this will come in handy later, not immediately, but it'll come in handy a little bit later. So same thing we did last time, identify the real part and the imaginary part for each number. So the real part is -8. And for this one here, the imaginary number, or the imaginary part is going to be -7. We don't really need the I part. And I mentioned that the last time. I mean, if you put the I part on there, it's not that big of a deal. But it makes the next part where we have to graph it a little bit easier. All right, now moving on to example number 2. We have an imaginary part. Right, so again, there's only one term here, so that's going to be 26. And A is going to be, well, let's see, what is A going to be? 0. All right. Now again, we don't leave it blank. We don't put nothing or anything like that. We put 0 in there because 0 is a number. And nothing is not a number. So let's go ahead and do this next one here, 15. So again, that's the real part. That's the A value. And our B value, the imaginary part, is going to be 0 in this case because there's nothing there. So it would just be 0. Now I have I, just plain old I. So I don't have a real part. And as an imaginary part, I only have 1. Now remember, the number in front of I, or any variable for that matter, if you don't see anything, it's going to be 1. Not 0, because if it was 0, then 0 times anything is going to be 0, and you wouldn't have anything there. But again, we've already done this one here, so let's kind of get what we're doing with, and I have the homework right in front of me right now. So, oh, sorry, not quite ready to go into the homework problems just yet, but I guess we're gonna have to kind of explain why imaginary numbers are a thing. I still got some stuff in my lungs, I guess. All right, I'm not sick. I just got some stuff in my lungs, that smoke. Wonder, like firefighters must have to have like their mask on the whole time because, like, man, it really does. You can really feel it. And the fire department took forever to show up too. Like the thing was practically over and all the way down to the ground by the time the fire department showed up. And I also heard that Tuba firefighters didn't even show up. It was Shanto firefighters that showed up. somehow Shanto firefighters got to there before the Tuba firefighters did. And it was like a whole hour, at least an hour. I don't know when it started, but I mean, like from an hour from when it was reported to when the response time happened, when the fire department showed up. Man, we got to work on that as a town, I guess. I don't know. But anyway, so let's take the square root of both sides here. So if I ask you what number squared gives me 16, well, you can work backwards and take the square root of both sides. And you would easily say, well, it would be 4. Now, sometimes there's a little bit of an extra explanation instead of just 4, because there's also another possibility, and that is x could also be -4. And it could be -4 because, again, -4, if you square that, -4 times -4 is positive 16. So you can take, you can even square a negative number, but having the result be a root doesn't work out. Because we can't take the root of a negative number because, again, I cannot pick 2 of the same number to make a negative. If I try 4 times 4, that's going to be positive 16, not negative 16. If I try -4, -4 times -4 is going to be positive 16, not negative. And again, I will get some students that say, well, can't one be positive and the other be negative? No, because if you square them, you are squaring the same number. So this causes something that just doesn't work out. But there is kind of a way around it. And actually, this is going to be the first example in the work. So we're going to go over how you would actually work with this. Because sometimes in a large equation, you'll have a lot of things going on, and you can switch out variables like x's and y's and all these other things. So you could turn in what could be an imaginary number and make it real later on. So sometimes it is worth it to completely simplify it. So that's why we have the I. So if we ever need to go back and work on it, we can. Now we're not going to do, I don't think we're going to do that with this course. It's something that's further on down the road, probably like future math courses. But anyway, let's go ahead and continue. By definition, I is equal to the square root of -1, and I square is equal to -1. So again, that was something that we did in the previous lesson, where we were multiplying the numbers. I to the certain power becomes this or that. All right, so now this is that first problem in the example. We have root of -16. Now again, normally this is not possible, so sometimes you would just write not possible or something like that. But you will need to keep working on some of these, so you have to keep working on the equation, and you might have to come back to it later, or something else might happen that will turn an imaginary number into a real number. Because I know when we say it real and imaginary, people oftentimes think that they're so vastly different, like they take up different universes or something like that. But that's not entirely true. And again, there's a lot more going on with imaginary numbers. There are some pretty good YouTube videos out there I suggest that you'd watch. I don't really have the links of them, but it would be nice. But you won't really need them for the homework. For the homework, what you need to know is, well, let's factor this out. So if you remember when we factor out radicals, so we want to simplify this radical. So we would oftentimes break it into numbers that we could use, like in this case, 4 times 4. And remember, we're looking for pairs of numbers to take out. But 4 and 4 would make positive 16, so how do we make negative 16? Well, we could put a -1 there, which -1 times anything will turn that number negative. Or we kind of give that negative its own number, so it can stand with that number instead of having to hang out with other numbers. So what's going to happen is we can take out a pair, because again, remember the index is 2 on a square root. So if I have 2 of these, they come out as 1. But I also have a little bit of a problem, and that is I have this square root of -1. But we can simplify that also, because remember, square root of -1 is equal to I. So what I'm going to do is I'm going to replace this root -1 with I. And there we go. Now it's completely simplified. And again, this is one of those things that once you get a little bit better at, you can just sort of work on it without having to write everything out, skip some steps, whatever you're comfortable with. Now for this one here, I am going to do the same thing. I'm going to put -1 because we want to take the negative away from whatever number we have so that it's positive. Now in this case here, I have 25, and I could break this down into 5 times 5 and take it out. But if you remember when we first started this lesson, I was telling people, get numbers that you know are square numbers. So 25 is a square number, and we already know that. So we can easily take the square root of 25. So I have root -1 times root 25. Because again, that's one of the properties of multiplying radicals. Multiplying radicals is that you can also take them apart, right? It's still factoring, but now I can take this square root of 25, because we know the square root of 25 is 5, and the square root of -1 is I, so I end up with 5I. And there you go. Now it's completely simplified. And this is a lot easier to work with than having something like this. And a lot of times, like if you ever need to really work with mathematicians, a lot of them will kind of already understand, what it is. So it's just a shorthand way of taking care of that. Okay. Let's go ahead and do this one. Now for this one, I'm going to factor it completely. So if we break down 20, we would have, well, actually, if it was -20, it would be -1 and 20. And 20 would be 2 and 10. 10 is 2 and 5. Now I can see what I have 2 of. I have a pair of 2 2s. And this -1. Now again, that -1 can come out. So I can finally, okay, I'm gonna take the 2 out, so I get a real number 2. And -√1, which by now is just I. But this 5 stays in there because we can't take it out. It doesn't have another 5 to come out with. So just like if you remember simplifying radicals from last week, sometimes you just can't take numbers out and they just sort of stay in there. And last one, I'm going to do this one a little bit quicker. So -1 times 2 times 25. And again, we're taking the square root of all of these. So square root of -1 is I. 25, we can take the square root of 25, so 25 is 5. But now we have 2 left in there, so we cannot take that 2 out. So it's going to stay under the radical. So 5I square root 2. And there we go. All right, so for this next one, it's going to be a little bit of a tough one. Well, not really. It's actually simple once you get to know what's going on with it. So here I have a graph that's very similar to the X and the Y. In fact, I just use an X and a Y graph on it. I didn't even bother making, with the imaginary graph, like the one we saw on the second slide when we started. I didn't. But you can use the same graph. It's still the same idea. So again, there's part real number, part imaginary number. So that can cause it to move left, down, up, or right in any direction. So as we start this, I'm going to go ahead and create a column for real numbers and another one for imaginary numbers. So the real number in this case, just like we did with that other exercise, look for the real number, it's 2. And the imaginary part is -3. Now again, we don't really need the I in there because it doesn't really make a difference. And I put it into an ordered pair form. I put it into an ordered pair so it's a little bit easier to graph. So if you remember graphing from any previous algebra class, pre-algebra, 8th grade, I'm sure you used them in geometry quite a lot also. So it's the same idea now that you just plot it using your X and your Y. Now I went ahead and labeled these, the homework, I looked it over and it does have parts that are, the numbers are labeled. So, sorry, the points are labeled. So real number is 2, so over 2, down 3. So that's this point here. And again, on the homework, they ask you to label them with the letter that they give you. And I had it somewhere right around here. I think I had to make another copy because a student had gotten the wrong copy this morning. So I had to go make a new one to send out. All right, so that takes care of that one. Let's go ahead and do this one here. So for B, let's get our real number, which is -3. And again, the signs go with the numbers. And plus 2i, so oopsie, messed that up a little bit. 2, so go back 3, up 2. That would be B. And there we go. That's it for that one. And last one does not have a real number, so 4i. Point C does not have one, so 4i. So the real number is not there, so it's going to be 0, just like we did in the previous exercise. And 4i. So again, the imaginary part is going to be 4. So this is going to be, okay, we don't go left, don't go right, just go up 4, and it's going to be right on the imaginary axis right here. So we're going to label that point C. Okay. And that's it for that one. So again, it's just as simple as plotting regular numbers. Now, I'm going to go over one more exercise and then we'll be done. Because when I went over the homework, I noticed that there are some problems where when you are simplifying the radical, there are numbers already on the outside. And I had the paper in front of me, but I think it was like 7 or so. 7 or so of the exercises have numbers already on the outside. So what do you do if there's numbers on the outside? Now we already kind of know what to do. I think we've done this one before, but in case you forgot, or maybe you want to be more sure when you're going over the homework. Remember, this is 5 times the square root of -100. So there is a multiplication there. You don't see it, but 5, and I'm going to go ahead and put a times in here. So -1 times 100. And you don't really need to do this every single time. But again, it helps to show steps. So 5, because the 5 is already on the outside, and I'm going to take the square root of 100. So square root of 100 is 10. But we still have this negative root 1. I'm sorry, I almost put I there. I'm getting ahead of myself. So 5 times 10 is 50. And root negative 1 is I. So I end up with 50I as the simplified answer. So again, pretty simple. Just do what you normally do, but take the number on the outside and multiply it by whatever comes out of that radical. Whatever comes out, just multiply it together. And that's pretty much all you would need to do. So we are done with that one. I am going to go ahead and end the lesson here. If you have any further questions, as always, I will be here for the next minute or two to answer anything you might have. Again, I wasn't here yesterday, so make sure you watch the video from yesterday. Yeah, you're gonna have to watch the video I uploaded yesterday. And that will be it for today. So if there is nothing else, I will see you tomorrow. Bye-bye.